Hi, everybody. Welcome. Episode number 5. We're going to talk about change feed today. My favorite feature. Yeah, it's got to be my favorite. I think it's my favorite feature. There's a lot of features in Cosmos that are my favorite, and I think this one just may be it. If you have never heard of change feed, this episode is for you. And this week, I've got Tim Sander back with me again. Tim, say hello.
Yeah, hey everyone, it's good to be back. So today, just like I did with Query a couple weeks ago, I'll give a deep dive into the change feed in Cosmos DB.
Cool.
So if you have any questions, don't be shy. We actually got some great questions in advance of this event, which is a first. So it's a great pattern to see. So I hope we see that for future.
I got questions lined up for you, Tim. So yeah, we're good. But yeah, if you got questions, just fire it up in YouTube and ask away.
Perfect. So this session will basically take you from 0 to 60 with the change feed in Cosmos DB. Doesn't assume any prior knowledge with the change feed, and we're going to focus a lot on the design patterns for how you use the change feed, and a lot of the internals for how the change feed works in Cosmos DB, and how the change feed processor, even more importantly, how the change feed processor library works. Next slide. So we're going to approach this through a scenario, because examples, they just make things a little more interesting and a little easier to explain. So we're going to build a sample application for a fictional company called Contoso Retail. First thing we'll do is ingest some data. Then we'll read from the change feed to send alerts if someone views a particular item. We'll then go and create a real-time materialized view. And then finally, we'll move data between Cosmos DB containers to just aid in the data model, right, for this type of scenario. And these 3 use cases of the change feed are super simple, and you could kind of extend these examples, to many other types of scenarios that kind of fit these same 3 buckets. Sending like alerts and event-based architectures, building materialized views, and real-time data movement. You can kind of bucket any change feed use case into one of those 3 kind of categories.
There's one more I'll add for you there, and I don't know, maybe it's covered in the move data, but maintaining referential integrity between 2 containers. So that's another use case, if you will. So if you've got like a product category and a product container, and you change the name of the product category and you materialize that in the product container, put a change feed on your product category container, and then when you change the name, you can update all the products.
Yeah, that's exactly right. Yeah, I put that in the 3rd bucket, but without a doubt, that is a huge use case of a change feed. Like super, that problem comes up so much. We will that'll actually be that 3rd use case that we'll talk about today. First thing we'll do before we even get into the change feed, just talk about just the type of data we'll ingest. So super simple. This is the item that we have. Basically, think of the raw data as like events to your retail website, where different users have carts, like cart IDs. They can either purchase or view an item, and then I think there's some other actions as well that they can do. Items have names, like a men's button-up shirt. They have prices, and then each user is in one of the 50 states in the US, and this is just abbreviation for Washington, like the state that I'm in now. Each event has a unique ID GUID as well, so that's good to call out. Now we're going to choose item as our partition key, because our most common query that we run includes item as the partition key filter. So that'll come up later, but for now, just keep in mind item is the partition key that we've chosen. Now, before I get too far into the demos and the session today, I do want to point out that all of the demos that I'm running are available in our change feed lab. So what I've basically done is took our change feed lab and turned it into basically a 1-hour session like this, where we'll go through why a lot of the decisions were made in the lab. So if you wanted to recreate something just like this on your own and kind of learn more, the lab is a great place to go that Mark just pasted the link for. So our app is basically going to use a cart container for ingestion. And then we're going to have different Azure functions subscribe to changes in the cart container. So a buzzword I always hear is like a microservices architecture, right? Like everybody loves the word microservices. Here, basically, each Azure function is a microservice, right? We have one that sends an alert. We have one that builds a real-time materialized view, and then another that sends data to another container. And the key theme here is each of these Azure functions are independent from one another, right? They each do one small, in other words, like one micro service, right? They do one small thing on their own. They scale independently, and they each have an independent and separate view on the cart container's change feed. So first thing we'll get into is sending an alert. So this is like the most basic possible use of the change feed. So we basically want to send an alert if someone views the item men's baseball hat. So if somebody goes on the website and there's a raw data that basically has the action view, right? And the item's men's baseball hat, we just want to send an alert. It could be an email alert, it could be a notification, whatever, like, but just some sort of alert. So I'll show you kind of what that would look like if we were to create that example here. So I've created an Azure function that's going to read from the change feed, and I'll go to my send alert function. And basically what I'm doing is super simple function. I've got my store database, my cart container, and I'm going to subscribe to the changes for that. And every time we get a bunch of changes, I'm basically going to check if the cart action is viewed and the item is men's baseball hat. And then if that's true, basically go and send an alert. Obviously here, I'll just print alert to the console or do something like that. Now, this code here, the code in your function, is going to execute every single time there's a update or there's a write on your cart container. So what I'll do is I will bring this over here and just start to generate some data. So we have some data in that collection. Now, the data that I'm going to generate is effectively, I mean, those documents that you just saw, right? They're basically sample retail events. So we'll go ahead and we'll generate some data. And then I went, and this code here, I just have this that I can start running locally as well. So here, basically, and obviously you could deploy this function to Azure if you were doing it. I mean, you were doing the lab, but I'm here just to keep it simple. On my local machine, ingesting data into my Cosmos DB cart container, and the Azure functions here will basically go and subscribe to those changes. And each time there's new changes, we'll execute the function. And if that particular condition's met, we'll send an alert. We might not actually see an alert come up this time just because it's pretty rare to see that item be viewed. But basically, each one of these executions here is just the function being executed again and again and again and again. So I'll stop that. And I will actually leave the data generator running because it'll be good to have more data later on. So that is basically the simplest possible use of the change feed, right? We triggered an alert based on the data that was written.
I love the ASCII art that Azure Functions throws up when you start the local emulator there.
I know. If you actually watch some of our older change feed videos, there used to be a PM on our team that got really excited anytime that ASCII art would come up. And he would do what I was just doing now and just run a sample change feed demo locally like that. You seen the big functions logo, he'd always get really excited. So that used the change feed, right? Like that was a super simple example. I mean, every time there's a new write or update in our cart container, we executed that code in the function. And obviously it was an incredibly simple function, right? There were 3 lines of code, an if statement, and then we printed if there was some condition were met. I mean, but that's how easy it is to read from the change feed. The change feed is something your mental model of the change feed should be, it's a sorted list of documents in Cosmos DB based on when that data was modified, right? So it's not actually a full operations log. So in the change feed, when you read the change feed, it's basically just a way of reading your data based on, when it was modified. When you read the change feed, you read it overall for the entire collection. So in my case, I just wrote my function, I deployed it, I ran it, and as there were new changes, as I ingested more data, I'll actually stop ingesting data for a minute now, since we have a good amount. As I ingested more data, during each new write, my function ran. And that was all automatic for me, right? I didn't need to do anything. Behind the scenes, there's actually one change feed per physical partition in Cosmos DB. And the change feed processor library, which Azure Functions uses behind the scenes, basically, I mean, orchestrates and coordinates all that for you. So, I mean, you could have 5, 10, 20 physical partitions, and the change feed processor library is going to manage reading from all of those basically for you automatically. So again, the change feed, you want to think of a sorted list of your documents in Cosmos DB based on the modification time. And the change feed will have the latest version of the document. So if you do intermediate updates, those aren't in the change feed. If you do deletes, those aren't in the change feed. But if you do updates or writes, we'll have the latest version of every document in the change feed. Now, the change feed processor library will give you fault-tolerant reading of the change feed. And the change feed processor library has something what we call at least once semantics. So we guarantee that if you run the change feed processor library, we'll process every change at least once. In other words, we're not going to miss a change. Like all these raw events coming in, they were business critical data. That's okay, right? Because we're not going to go and miss any of those raw events coming into Cosmos DB. Now, the change feed processor library will manage polling and checkpointing for you automatically. And we use something called a leases collection to maintain the state for the last process change of the change feed. This is all managed automatically by the change feed processor library. I'll show you a quick example of what the leases look like. Here I have this Cosmos DB account that I've been using in the example so far. I come to my Data Explorer, come to my store database. You can actually see the leases that I'll be using throughout the presentation today. So if I go to the Sent Alert lease and look at the items here, you can see basically different bookmarks you have for the different physical partitions behind the scenes. Now, the good news is, as a developer using Cosmos DB, you don't have to manage these lease collections. You don't even need to know what physical partitions are. All you do is set up the function, set up the Cosmos DB trigger to read from the change feed, and this lease collection will automatically be created for you. In my code, I actually have a create lease collections if not exists is equal to true, and specify the lease collection name here. So for me, I actually never needed to create the lease collection. By putting this into my function, it just did that automatically for me. Now, again, this lease collection is automatically managed, and as we progress through reading the change feed and read more and more changes, we'll go and update, this bookmark here per physical partition, which will basically give us the last document that we processed reading from the change feed. Now, again, it's one change feed per physical partition. So if you have, let's say, multiple physical partitions, that's going to be the unit that we use to parallelize reading the change feed. You as a developer do not need to do anything to think about that or worry about that, but just know that behind the scenes, the change feed processor library, and which functions uses, is going to parallelize the processing across physical partitions. Now, if you're operating at a really large scale, change feed processor library could be something that you want to go and deploy on your own. Potentially, you might even want to have several different instances of the change feed processor library consuming from the same collections change feed for better parallelization.
And those are going to span across physical partitions, right? Either a range of them. Like, I guess if I had 2 change feed, if I had 10 physical partitions and I ran 2 change feeds, they'd split it by 5, right? So you'd basically running half of them, 5 of them, the other one running the other half. And then if I added another, it would split it by, well, I guess 3, 3, and 4 in there. That's kind of how that works, right? When you scale out like that?
That's right. Like if you had multiple change feed processor instances and they were sharing the same lease collection, if you wanted to do that for better scale, that's right. They'll each basically subscribe to the changes for a subset of the physical partitions.
So now, the maximum number you could get is bounded by the maximum or by the number of physical partitions.
Right. Yep. That's the max parallelization that you can get
okay.
right now.
And then if I wanted to go any faster, would I need I guess a larger functions instance then? Is that like, say I'm falling behind in my processing or whatever?
So, there's a lot of different ways that you can go and read the change feed, right? We just did it with functions, and function has a consumption plan, a premium plan, and that's great if you're reading the change feed at a small scale. The beauty of the consumption plan of functions is you write your code, deploy it, and that's it, right? Super easy. And for most small and medium scale apps, that's going to be more than enough. And that'll actually scale automatically for you. However, if we're talking really large scale, it could be worthwhile to consider functions premium. Potentially just on the pricing aspects alone, functions premium could be good. Functions premium also doesn't have the cold start that functions consumption does, so it'll be more steady, more consistent performance. And finally, it could give you like a better upper bound in terms of like how far you can scale and the performance guarantees that you get. Same benefits apply to the change feed processor library. Like functions, you should think of as basically a platform, like a hosting platform for the change feed processor library that's just managed automatically for you. If you were using change feed at a really large scale and you wanted more control over the scale, you could go and deploy the change feed processor library on your own.
You recommend that. I do too. One of the things is the function bindings are using our older SDK, I think, still, aren't they? They're still using the V2.
They are, yeah, that's exactly right.
So you're going to get better performance if you just create an empty function and then drop change feed processor in there and then just use the same boilerplate code in there, right? Because if you're using our later SDK, there's always performance improvements with
that's
right?
Yeah, I'd say that is certainly a good benefit of the change feed processor library since it's baked into the V3 SDK. Functions does use V2. So that, I completely agree that is like a slight nod towards processor library as being a little better. The big theme is like processor library, you have more control over scale. Functions, scale is managed for you, right? Because it's a PaaS service. Now, there is a difference, and this actually, it's in our docs, but it might not be initially apparent to you if you're just trying out the change feed processor library and functions. I had mentioned that the change feed processor library has what we call at least one, I'm gonna go back here, at least one delivery, right? At least one semantics. Now, the way this is handled is slightly different in functions and the processor library. If I run my code, right, we'll call it the delegate, like when there's a change, the code in the delegates run that, let's say, sends the alert or something like that. If there's an exception thrown in that code, if you were using the change feed processor library on its own, we'll go and retry those changes again, basically. So the idea is if there was any unhandled exception in your code, any error, it's not gonna be a silent failure. We'll go back and we'll retry that again and again until it's successful. So the recommended pattern is if there's an exception, catch the exception, and then the document that led to it, write it to like a dead letter queue for later processing, right?
How many times do we retry by default?
Oh, we'll just keep going.
Oh, so serious?
Right? Like eventually,
right.
Like it could get stuck, and you just keep retrying again and again and again and again.
Yeah.
We do this to give you at least one guarantees, right? Because if this was really business critical data, you don't want to miss it, right? If there was like an unhandled exception, like you might want to. It might be something important that you didn't want to miss.
Yeah, but it seems kind of odd that we would retry infinitely on something. There's got to be a limit to that, right?
Maybe. I don't think so. It should just try. Now, functions, on the other hand, functions will just move on.
It will. Okay.
Because functions
sounds more normal to me.
That sounds more, yeah. So the thing is, most users who use the change feed actually do use functions because it's just the easiest. It takes you a fraction of the time that it does with the processor. Because all the deployments managed for you, right? Like you write your code, click, and it's ready. With functions, a lot of people use consumption-based pricing on functions. So if you think about it, right? If we were doing this retry over and over and over again, and you were consumption-based pricing, like your bill is going to go up, right? Like crazy, right? It's going to be So with functions, we just move on. So if there's a failure, we guarantee that we're going to go and try to process every document. But if there's, let's say, an unhandled exception or an error, we move on. So the recommendation is the same. Like you still would want to catch that, figure out like why it failed, and then understand what that document is so you can go process it later, right? But I mean, what happens if you don't handle it correctly is slightly different. So that is a key difference between the two that is definitely worth highlighting now, and I'll bring it up again later in the presentation.
Hey, so want to take some questions? I got some questions.
Yeah, let's do it. Let me see if I'm at a good spot in the slides. I think I am. Okay. Yeah, this is actually a perfect time.
Okay. Well, this one's related to what you were just saying about scaling for partitions, but how to receive feed per logical partition using Azure Functions. Is that possible?
So right now it's all per physical partition, and this is not something that you have that much control over with the change feed processor library. So the beauty of the change feed processor library and functions, like the big benefit is its ease of use, right? We manage scaling for you in the case of functions. We'll do the parallelizing of the processing for you automatically. So for now, when you read the change feed through the change feed processor library, whether it be functions or just a library on its own, you can't control whether you're reading just one partitions or not. However, we have something new called the change feed poll model. That's pretty cool. And if you wanted to read with a poll as opposed to a push model, and we'll talk more about how the push model works in a second. If you wanted to read the change feed with the poll model, our assumption is that you as a user want a lot more control over reading the change feed. So with the poll model, we actually expose the ability to read a particular partition key's changes. So not just physical partition, but a particular partition key value. Like if you wanted to only subscribe to that partition key's changes and only read one partition key's changes, you can do that with the change feed poll model.
Oh, that sounds cool. I got to play with that. I got so some more questions for you. Does the lease container cost RUs?
It does. We'll get into actually how many RUs you need in the lease container later, but even for the biggest workloads using change feed, we're talking like at most a few thousand RUs. Like if that, for almost every scenario, 400 RUs is enough for the lease container, which would work out to be like, I don't know, 50, 60, 70 cents per day, something like that.
Yeah, you can. I run it always on like 400 RU, I think.
Yeah, you don't need more than that.
$24 a month. I mean, you could even stick it in a. You could even use shared throughput for the change feed for the leases container. So it's even cheaper if you got more containers you can put in that same database. All right, a couple more questions I'll run through here. You talk about querying data directly from the change feed.
So querying data directly from the change feed. So for like, I guess there's two ways to read data, right? That kind of at a high level, you could do a query or you can read from the change feed. And with the query, if you have like a where clause, right, that you use to filter. In the change feed, like there's nothing like that that's baked into the change feed right now. So if you wanted to go and filter the results that you got from the change feed, you'd actually put that in your function. Like you put that logic, similar like to what I did with that if statement with the action and the item, you'd actually go and put that logic in your function. So there's no way around basically having every single change trigger the function. In the future, we actually want to give you the ability for when you read a change feed, actually be able to specify a filter predicate. So specify a where clause, so you could limit the amount of data returned by the change feed to, I mean, whatever the results are.
That actually would help Kazuyuki, who wants to filter or just do it by logical partition, because if you had the filtering on there, you could filter by the partition key.
That would totally work. I mean, you wouldn't be limited to partition. You could do whatever you
do it on anything.
Yeah.
Yeah.
So it's not supported now, but it's something that we do want to support in the future.
Yeah. Okay. Last question for what we got. This is the one that came in before we even started. Can you talk about how change feed works in a multi-region Azure Cosmos account?
So here, there's not too much to worry about. You should think of the change feed as basically just another way of reading your data in Cosmos DB. So in the same sense of, I mean, what things should you worry about if you have a query, right, in a multi-region Cosmos DB account? Like the same things I would mention for that, I mean, apply to the change feed. One, there's nothing really you need to worry about too much. Like you'd still use your global connection string. One thing that does come up from time to time is the question of how can I save RUs if I have a multi-region scenario? Now, sometimes your change feed reads will actually be a little separate, right? You might have like your core application that like sends requests against one container, and like separate from that, you might have like a functions instance that processes the changes and does all this stuff. It's possible if you have two regions and you have a region that's only there for like, I don't know, disaster recovery purposes, right? You could read from that region's change feed, since it just has all those RUs sitting there and available. Since maybe change feed reads, they're not as latency sensitive, right? So they could go to a region farther away. That's, I'd say, one thing to keep in mind that might not be immediately obvious, but otherwise there's not too much you have to consider with multi-region scenarios with change feed.
Yep, cool. Okay. Yeah, let's keep going.
Cool. So the next thing that I'll talk about is how the change feed processor library works. So the change feed processor library, the big benefit is it abstracts away a lot of the challenges in working with change feed. So here I use the functions icon. It's going to actually represent the change feed processor library, which is it's used in functions, right? So obviously this is talking about it in the context of functions, but if you had change feed processor library without functions, like this would all also be true. So Azure Functions will automatically check for changes. And if we find a change, we'll return that. But if we don't find any changes, we'll wait a specified feed poll interval before checking for changes again. And let's say we check and we find document A. We'll go and process that, right? But immediately after we get document A, we'll check again for changes without delay, and we'll find document B. We'll go and process document B. And after processing document B, can you guess what we do next?
Process it.
Process it, and then after that, we check again, right?
Check again, yeah.
So every time we process a document, we check again immediately. However, if we don't find anything, we'll wait like the specified interval that you specify when you're in your function or in the change feed processor library before checking again.
Can you specify the poll interval in the function binding, or in, I guess in both, either in the functions binding or in change feed processor?
Yeah, you can. I actually have never done it in functions myself, but I've done it in the library. So you should be able to do it in functions. Most of those parameters are exposed there as well. The idea is it's something you can tune, right? Like you can set it. I mean, it's based on the nature of your data. If the data was changing a lot, you'd obviously want to set it to a small number. It's not changing a lot, like maybe a small number is overkill. Every time you check for changes and there's no changes there, there's a small RU charge for that. So it's not very much. It's like 2 RUs or something like that. But it's a charge per physical partition every time we pull for changes and there's no changes received. So, I mean, let's say we waited, we checked, we see document C, we return that, we process it, and so on. And that just repeats itself. You don't need to handle that. You don't need to do very much. In most cases, when customers are using the change feed, like there's so many changes that it's nearly continuous. And all of this happens through using the change feed processor library automatically for you on a per partition basis, essentially. Now, next thing we'll talk about is how to build a real-time materialized view with the change feed. So far, we went and we sent alerts. That was all good, super, super simple. Take it a step further now and talk about how you could build a real-time materialized view using the change feed and functions. Now, let's say you want to do this scenario here. You want to display the last viewed item for each cart ID. Like this would be, if you imagine a retail website, right? Like you're going and shopping on your favorite retail website. You go and you buy something or you view something, and they might want to send you an email, right? Based on your last viewed item. Like you might go on Contoso Retail site and view like men's sunglasses, right? And you might view it, you might log off, and later there might be a microservice that says, okay, like we want to send Mark an email to encourage him to buy these sunglasses, right? So for that cart ID, we want to basically, I don't know, do some action based on that. So you have 2 options for this, right? You could query for that data each time, or you could build a materialized view. So this is what our query would look like, right? If we did it with the query approach, when we want the latest item, if we were to query the raw data, it'd be something like select top 1 from C, where cart ID is some value, action is viewed, and then we're ordering by timestamp, right? Now, if you remember my last, the last video we did together, what's like one way you'd want to optimize this query if you ran it, right?
Composite index for sure.
Right? So it's a little bit of a tangent. I gotta find my, my portal here. It's a little bit of a tangent, right? But as soon as you see that query, like a light bulb should go off in your head that says composite indexes. But for our purposes, we'll run it without a composite index. But I mean, obviously, if this were your actual application, you want to repeat this test with a composite index to check the performance. Now, I'm going to run this query here against my cart container, right? And what it's doing is it's going to filter to this value where the action is viewed and then sort by timestamp, right? When I run that, RU charge is about 98 RUs.
Wow.
So it's hefty, right? Now you could implement this with a composite index. Like without a doubt, you could. But without a composite index, and if you could extend this maybe to a query that, let's say, maybe you couldn't optimize with a composite index, I'd say it's a hefty RU charge, right? And even if this wasn't 100, even if this was only like 20 RUs, maybe after you optimize it, and this query is going to be run so much, right? If you can imagine how often we'll run this for each user, I mean, it's really one user per page refresh, or maybe when a user logs off. Like if your website's popular, it has the potential to be very costly. So we have two options, right, for building this. We could query for the data each time or build a materialized view. So we just look like what it would look like to query for the data. Now let's look at, what it would look like to build a materialized view. First off, materialized views, if you're a developer that's used databases, you usually will know what a materialized view is. Basically, we're taking a subset of the data, and in other words, taking a query result, right, and basically pre-computing the query result for an easier lookup later on. So that when you run the query later on, you're not running it against the raw data, but you're running it against a subset of the data, basically a view that we've materialized that has your query results for easy lookup. In a lot of relational databases, materialized views are like, there's something that you can set up kind of built in, right? Like it's you don't need to go and create it on your own. With Cosmos DB, you build a real-time materialized view using the change feed. So same concept as relational databases, but here we're going to go and build it with the change feed, just with a few lines of code in an Azure function. What we'll do here is super simple. We're actually not going to do any complicated aggregates or anything like that. We're basically going to take our raw data and send it into another collection. So remember, we have that cart container where we ingested data, and it looks like this. What we're going to do is send that to another collection, our materialized view collection, and send that same data there. But what we'll do basically is make it so the cart ID now becomes the ID value. And the partition key will be the ID value. So that way we know that ID is globally unique in this container, right? If ID is unique per partition and each partition key is unique, we know that if we have one materialized view document with this ID, and we go and we add in a new one and we do it with upsert, if it already exists, we'll just go and replace it. And that way, if we have a materialized view container that has each cart ID represented like this, where we have the cart ID as the ID and the partition key, it's very easy to access this data with a point read, right, instead of a query. And we'll do some rough math for what this looks like. In the first scenario, where we wrote data to the cart container, you can imagine it costs you about 5 RUs, right, for a small document, give or take. We run that query. I rounded off to 100 RUs, but I think it was 98 when we ran the example, but yeah, close enough. We say we're running that 1,000 times per second. We have a pretty big app, right? 1,000 times per second is a lot. If you do the math, like it actually is, and I think my math here is right. I think I might have actually added an extra 0 here. So this one's 100. It's not 1,000, but close enough, right? You're pretty close. No. It's around 100,000 RUs.
Right.
Expensive. Now, if you build a materialized view, we're basically going to do a write to the cart container. That's 5 RUs. It's 20 operations per second. We'll go and actually end up reading from the cart container again. So you'll have one extra read here that's not included, but it won't cost too much. You'll go and you'll update the materialized view container, which will cost you around 9-10 RUs, right, for an update, since they're a little more expensive. So this will be higher, right, because we now need to go and duplicate, potentially do a duplicate operation, right? We need to do an update in addition to the write. However, because this is such a read-heavy workload, the read from the materialized view container, instead of costing 100 RUs and having an order by query, we can just do a 1 RU point read, because we'd have the ID value of that document.
I want to point out something here. I get this question a lot, is how many RU do I need on Cosmos for my app? And the thing I tell them to do, I say, is they need to make a table for every operation inside there, measure it first, whether it's in the SDK or in the portal or whatever, and then multiply that by the number of operations per second, so they can figure out what that is, and then just sum the whole thing up. And this is exactly what you've done here. And I just want people who are new to Cosmos and are trying to do capacity planning, this is exactly how you want to approach it when you're trying to scope out and estimate how much RU you need, is taking every operation that you're doing, like whether it's purchasing an item or putting up a product page or whatever, and then measuring all of the RU for that, and then multiplying it by the number of concurrent operations per second, because throughput in Cosmos is amortized, is measured every second, right? So that's anyway. Just thanks for showing that, because more people need to see a like a table like this, because this is how you figure it out, right?
Yeah, absolutely. I mean, this is what you want to do when you're thinking about how many RUs you need, data modeling, right? You literally want to list out every operation like this. Now, as like a new user, you might not know every operation, right? You might not have actually, like here I've ingested some data and I ran the query against it. As a new user, you might not have been able to do that yet, right? Like you might just be starting out, maybe you've just tried out Cosmos DB a little bit and you haven't ingested much data. So you want to be as precise as you can. Like if you can't be that precise, it's still worthwhile, like Mark said, go through this exercise. Even if you have to estimate, like a query is 50 RUs, a query is 100, and a point reads 1 RU. That's okay. Like that's still better than just kind of pulling a number out of thin air.
That's right.
It's you'd be amazed, even putting in like kind of rough numbers, how accurate this is going to get you. I mean, again, as just a rough mental model, writes of small documents are going to be about 5 RUs. Updates of small documents, you could figure like 9 or 10 RUs. Point reads of small documents would be about 1 RU. Now, where it gets a little trickier is if you have queries. That's where you actually have to go and run it. But I mean, for simple queries, I mean, it's generally not going to be more than 10 or 20 RUs. For queries with order by, could be higher unless you have a composite index. So you could estimate like 100 for like a more complex query with an aggregate or order by or something like that.
Yep.
I mean, when deciding whether to build a materialized view or not, you actually want to go through this exercise. And if it's a read-heavy workload, oftentimes building that materialized view, I mean, could change the cost by like a factor of 100.
Yeah. Yep.
So, I mean, first thing we did was we built a microservice that sent an alert. Next thing we did was and I'll show the demo in a second. Basically, we build a function that, I mean, builds a real-time materialized view and persists that in a materialized view container so that when we go and access the data and run that query, it would be a point read against the materialized view container. We'll never actually need to go to the raw data in the cart container. So I'll show now what that would look like. Basically, I'll pull up my materialized view function. It's not going to be very much code. That's the thing, right? Like just like before, we have our function here, and we use the Cosmos DB trigger, and we specify what change feed we're subscribing to, right, in a cart container. We specify the lease collection name, and since this is a different function that has an independent view of the change feed, we need to have a different lease collection for it. So in this case, the lease collection is going to be materialized view releases. If you remember before, we had, I think it was send alert leases, right? It was a different lease collection. Now, when we go and we process the changes, basically we'll go through each of the changes. This function will be triggered, right? And we'll check if the cart ID or if the cart action is viewed, then we'll go and basically update that particular item in the materialized view container. Like it's super simple logic. Like the function doesn't have very much going on in it. And we basically just have this if statement here to check and see if we have to go and update the materialized view. Now, I'll go back to the portal because I had mentioned that we have 2 separate collections now, right? Or 2 separate functions. We have the alert one and the materialized view function. So each of these actually have separate lease collections. Like we have the materialized view leases. Actually, it looks like I created duplicates, and the send alert leases. I think it's this one that's being used. Oh, I'm sorry. This is the materialized view collection. So we have the materialized view leases right here, where we have the bookmark for the materialized view function, and then we have the send alert leases. So we have basically separate bookmarks for each function, so they can progress reading from the change feed independently. On this materialized view collection, basically, like I mentioned earlier, basically has the same schema as the raw data, but it just has that ID value here for easy lookup and just has the latest version of each document. So I could just look up this document with the point read for 1 RU. So again, the leases that you have are all independent from one another. So at the beginning of the session, I just had one microservice that read from the change feed. And as we progressed in reading from the change feed, basically our lease had a different bookmark for that continuation for the last process document. And over time, we left our code running, it progressed farther and farther and farther. Later on, like now, we just added a second microservice. So my function that I'd run earlier, like if I go and just run it again, I guess I won't show it because it's not that exciting. It would just keep re-update my container. But if I go and start that function and run it, I have a second microservice, or my second function, go and read from the change feed. And these bookmarks would be independent from one another. Like just because I had progressed farther with microservice 1, microservice 2 can have an independent bookmark for where it is in reading from the change feed. Now, least container best practices, like super simple. I mean, this is a formula that we use for computing how many RUs you probably would need in your lease collection. I'll save you some time. In most cases, if you fill in numbers here, the answer is going to be 400 RUs. Number of hosts, I mean, it's probably going to be not that high of a number if it's a small scale, probably like 1 or 2. Number of physical partitions, probably, again, not very high number. So if you just fill in some sample numbers, like 3 hosts, 5 partitions, we get less than 400 RUs. So it's only gigantic scenarios where you would need more than 400 RUs. So, I mean, 400 RUs, maybe even like a shared throughput collection within a shared database throughput collection. Like even that is probably more than enough. So that was the first 2 out of 3 functions that we built. The last one will be about moving data to another container. So in our app, these are the most common queries. Select star from C, where name is, or where item is some value, right? In this case, men's button-up shirt. We want to filter by a particular item. And the second would be sum all the prices from people who basically bought items in a particular state. So the second query would add up all the prices from purchases where the buyer state is Washington, right? You can still hear me okay, right?
Yep.
All right, cool. Wasn't sure. All right, perfect. Where we basically sum all the prices from the buyer state of Washington. Now, do you remember what our partition key was? Do you think back to the beginning of the call?
Was it item?
It was item.
See, I was listening.
You were listening, and I hope it all comes together now, right? Our partition item. And the first query that we run is an equality filter on item, right? That's one of our most common queries. That's in partition. Right? Like if you remember our call from 2 weeks ago where we walked through cross-partition and partition queries, you always want queries, if possible, to be in partition, especially if they're queries that you run quite a bit. So that first query, the green part's in partition. That second part, obviously, it doesn't have a filter on item. We filter on buyer state and the action. So this query is cross-partition, right? We need to go on every single partition and execute the query. So we'll do a quick demo of the query charges. Nobody should be that surprised by what they see here. If you think back to our talk from 2 weeks ago, basically the reason cross-partition queries are expensive is we need to run the query on every single physical partition. So with an in-partition query, like the one I'm about to run here, the in-partition query, we're only going to run the query on 1 partition. So this one just didn't have any results, but I mean, the charge was super cheap, only 2.7 RUs. The reason for that is, I mean, this is partitioned on item, so we only ran it on the partition where item is. We didn't need to go run it on every partition. Now, if we run this query here, the one that sums the purchase prices of every item in Washington, this does not filter on items. So we'll need to go and do this aggregate on every single physical partition. Charge here is about 30 RUs. So like I mentioned, we got 10 physical partitions. So I mean, if the charge is 3 RUs in one, it's 30 RUs in 10. Like that kind of makes sense, right? The query cover charge here, right? The base cost for running a query is almost 3 RUs. So that was actually most of the charge of this query here. Now, obviously this isn't ideal, right? Like you don't necessarily want to be paying for a query that you run quite a bit, 30 RUs. Like it's not that high, but if we could get that cheaper, we certainly do want to do that. So what we'll do is similar to what we did with the materialized view container. We'll create another container, and it's going to be called cart container by state, where it's the same data that we have in cart container, except instead of partitioning by ID, we just partition by buyer state. So this is exactly what you brought up in the beginning of the call, Mark, where you have data in different places, and it's basically keeping the referential integrity, right, of the data that is in 2 different locations. In this case, it's just simply replicating the data so that it can be partitioned in a different way. So I'll show a quick demo of this. Basically, what I'll do first is I'll go and start up my data generator. And here I have a change feed processor. Why this guy didn't start? Let me stop him, start him again. And I'll go and also create, start my change feed processor library as well. So there we go. Cool. So basically, what this is do here is it'll generate data. I'll go restart this guy as well. Oh, there we go. Didn't need to do that. Spoke too soon. This will go and generate data, and then my change feed processor, my app that I this time I use the change feed processor library for. As the data comes into the cart container, we'll go and replicate that into the cart container by state, right? So here we're ingesting data, and then here as the data comes in, we'll receive the changes, and then go and write them to the cart container partition by state. So here I actually use the change feed processor library instead of functions. The code here was pretty simple. Similar to functions where you specify, the business logic in your function. Here, all we're doing is printing the number of changes that were received, and then basically going through all those changes and do our container that partitioned by or state. Nothing really fancy there. Pretty short business logic. That same polling that we'd done earlier, that was handled automatically with functions, is also handled automatically with the change feed processor library. So we'll go ahead and stop processing them for now, and I'll let the data generator just run a little bit longer. Now, what this will do basically is it will go and replicate the data across basically two different locations, right? So some of your queries will go to the cart container collection, and some of your queries will go to the cart container by state collection. So of course, this is eventual consistency, right? Like depending on where you query the data, you could get a different result. In practice, we find that if you were to do this approach and your change feed is reasonably up to date, and your processing the change feed is reasonably close to like the new data, you really won't notice very much of a delay. Like it usually looks like
a few seconds maybe.
Yeah, not very much. So I mean, use this pattern in really business critical large scale production apps because it saves them a lot of money. Now, of course, if you use this, you do have to be okay with potentially a few seconds of staleness, but in general, that's like the most you'd see. What's pretty cool, and this is actually what I pulled up here, is it's really easy to go and monitor how far you are in processing the change feed. So if you notice, like before, a second ago, I went and stopped processing the changes, and I went and started a console app that uses something that we call the change feed estimator. And the change feed estimator is basically going to look at my leases collection and tell me how far I am from processing the most recent changes. And it does it on a per physical partition basis. And you can kind of see that I'm really far behind. So as I ingest more data, like these numbers are increasing because I've stopped processing the data, but I still continue to ingest more. So
this is so cool. I love this feature because you could literally use it to drive scale up and scale down.
Oh, right, of your app that's processing the changes or something like that. Totally makes sense. Yeah, I mean, you could totally you could send alerts based off on it. Like if you were falling behind, like that might trigger an alert, right? That you're falling behind getting the changes.
Yeah, just set a threshold. Like if you get over like 10K behind, add an instance, and then just on a regular, you could do like a timer trigger on that, and just say check every 5 minutes, 2 minutes, whatever it is. But you could literally use that to kind of put kind of a scale structure around change feed processing. So
without a doubt, like you don't want to fall too far behind. So like what I've shown here is because I let this data generator get way ahead of my change feed processor. So I mean, this is exactly what you don't want, right? You want this to be either 0 or pretty close to 0. But again, you want to monitor this, right? If you're depending on the consistency of the data, this will give you like a way to quantify how far you are, right, in kind of replicating those changes. So that's how real-time data movement will work. Kind of going back again, like we talked about how important it is. do some rough math to figure out, I mean, is it better to replicate the data, or is it better to keep the data all in one collection? So if we just had a cart container and we didn't have the cart container partitioned by state, obviously this query is cheap, right? The one where we filter by item, we say 10 RUs, but it's probably even cheaper than that. But the query where it's cross-partitioned, here I use 50 RUs as my ballpark number, but I guess we just ran it and it was 30. We could use 30 in the estimate, and when you go and do that math, we get 3,100 RUs. Now, if you replicate the data to buyer state as well, you still pay for the right to cart container. This query is against cart container. It's the same cost. However, this container will be against the buyer state container, right? It won't be against cart container. So it's going to be substantially cheaper. So of course, you still have to do the read of cart container. You still have to write the data to cart container by state, right, and replicate it. But if you ran this query enough, like this starts to be where, like, I mean, this is going to be cheaper than this scenario. I can actually, since we ran the change feed processor for a while, and I had actually ran this for a while earlier today, so there's actually quite a bit of data in here already. If you remember, when I ran the aggregate query against cart container, it cost me about 30 RUs. If I go and I run same query, but against, which one do I want? I want cart container by state, right? It's just the data partitioned by state. If I run it here, seems like I have to refresh the portal. Sometimes that happens if it's going to work.
Yeah, portal, yeah.
So I'll go refresh it. We'll go back to cart container by state, right? Which is partitioned by state, same data. Run the query here, 3 RUs, which is super cheap. And the reason is it's an in-partition query, right? Even though it's an aggregate, it's actually still really cheap. The reason for that is it's in partitions. We ran it 1 time instead of 10 times, right? Because we have 10 partitions. So that's a key design pattern in Cosmos DB, right? Sometimes it makes sense to replicate data. Now I got a question for you, Mark. Like, I just replicate data. Won't that make my bill go up? Like, I'm paying twice for my data stored.
Well, it goes back to, well, first of all, storage is cheap, right?
Yeah.
I mean, this phone I've got right here, I got a terabyte of storage in this thing, and it cost me, I don't know, $400 or $500.
Yeah.
So storage is cheap, right? Compute's expensive, right? So running that cross-partition query 50 times a second is a lot of money, right? Because you're chewing up a lot of RU that you're paying for. So if you can do the same thing and use less RU, then you're saving money, aren't you?
Yeah, it becomes a math problem, right? You want to figure it out for your scenario. But like you mentioned, the reality is, I mean, memory is cheap these days, right? At 25 US cents per GB, like if you had a 1 terabyte app on Cosmos DB, which is pretty big, I mean, how much would you pay per month? Like we're talking, I think, what is it? What would it work out to be? Like 1,000 times 0.25, $250 a month?
Mm-hmm.
Not compared to what your RUs would cost. And I mean, I imagine your cost for like the app for a workload that large, like it becomes less than rounding error, right? Like it's just small. It's all about the RUs, right? When you're thinking about cost in Cosmos DB, forget about the storage. Like it's not going to really amount to very much. Really focused on the RU charges of your operation. And if you do need to replicate data, if you need to maybe create a materialized view to improve the efficiency of read operations, the change feed is a really awesome way to do that.
And don't forget, if you find yourself in a situation where not just one query has high concurrency, but a bunch of them do, and then you have this aha moment of, oh, I picked a really poor partition key. Change feed again to the rescue, because you could use it to migrate all of your data into a new container with a good or a better partition key than what you had, right? So there it is. It's just the feature that just is so useful and can use it for, I mean, can save your butt, I guess, to put it bluntly, for poor design decisions, or just to help you do these kind of analytical queries, if you will, or ones that just don't fit because you've got even more high concurrency queries that are in partition, but you still have these that you have to run at high concurrency as well. So it's great in that sense, right? And also for I find with where you have scenarios where you have to solve for both high write, high volume write, and high volume read. you have to design a partition key strategy that's both going to help spread that load across high cardinality partition key, but rarely does that ever work just to answer queries. So there you've got a situation where you've got to write it using one partition key, and then everything else on the read path is going to use a second separate partition key. So you've got to use change feed to take all of the data you ingest and then stick it into a new container with a new partition key. So
that's right. Yeah, I mean, that scenario, right, where you have a write-heavy workload that's also read-heavy, because if you ask a customer, right, when I'm working with customers and you ask them, do you have a write-heavy workload or a read-heavy workload? Very often, the customer will say, I have both. I get lots of writes and I have lots of reads. Like I don't just get one, I get both. And the answer here is maybe you should have separate collections, one that's optimized for writes and one that's optimized for reads. And that's exactly what we had, like in the example today. So again, I had mentioned at the beginning, if you like this example, you want to run it on your own, you want to play with it, it's all available online in our labs. It's our change feed lab. It's lab 8 in the labs that Mark will share in a moment.
There we go.
So you could run these demos on your own. The ones in the lab are like slightly different. I've made these a little simpler just to make it easier to explain. But I mean, same core concepts and same code that you can go and get started with.
Got a question. This is a great question from this gentleman here. Again, same old question. How to handle deleted data from materialized view and I guess a container where you're copying data.
So if you have change feed deletes, they're not going to show up in the feed, right? We only get notifications in the change feed for writes and updates. So if you have deletes, the workaround that we recommend is to go in your app and do what we call a soft delete. So you'd have basically an isDeleted property in your app. And when you want to delete the data, you'd go and you'd set isDeleted to true. And for your application, right? Effectively, when isDeleted is true, you pretend as if it were deleted. So I mean, queries that you'd run would set like isDeleted to false, right? Because data that was deleted, you wouldn't want to be there. So by setting the isDeleted property, basically the soft delete, by setting that to true, it'll trigger as an update, right? So it'll show up in the change feed, so you can go and process that. And then what you do is you'd set a time to live, a TTL, on that particular document, set it for like a day, so that after you got a chance to process it in the change feed, after a day, it would be deleted, right, via TTL out of Cosmos DB, and then it would actually be done. That's the workaround we recommend right now. And for most customers, like that does the trick, right? It works well. Now, in the future, and I'll actually talk about this 2 slides from now, we're actually working on supporting, in the near future, actually very near future, supporting all operations retained in the change feed. So in addition to having deletes, we'd actually have a full operations log of all the updates in the change feed. And if you're interested in that feature, I'll share some details for how you can sign up for the very early private preview. But if you read from the change feed, basically there's no cost. The change feed is a free feature. Like not much is free in life, not much is free on Azure, except Cosmos DB. Cosmos DB is free. The change feed is also always free in Cosmos DB. So, I mean, you could be a customer that has 400 RUs provision, change feed is still free. No matter what scale you're using Cosmos DB, change feed is and always will be a free feature for Cosmos DB. So no cost, it's always enabled. Think of the change feed as basically just another way of reading your data. You're charged about 2 RUs each time you check a physical partition and there's no new changes. So when I had shown the change feed processor library earlier and shown how the polling works, if you check for changes and there's no changes, there's a small, pretty insignificant RU charge associated with that. And again, the change feed just has the latest version of every document. So it is not a full operations log. It is just a way to basically read the latest version of the document based on the modification. Now, handling errors, I talked a little bit about before. You want to add try-catch logic in your functions so you can catch exceptions, and then basically persist the exception to a dead letter queue. So, I mean, Azure Storage, Service Bus, like these are all good examples of what you could use to basically store the failures for later processing. Now, remember, functions will move on. Change feed processor library, if there's a failure, we'll just retry that batch again and again. So, I mean, the best practice here is you don't want gigantic functions. You want smaller functions. So if there's some sort of like error or failure, like some of your business logic failed instead of like your entire app failing, right? You want like some apps might have dozens of functions or more. And then finally, this is the roadmap for the change feed. So right now in public preview, we have our change feed pull API. So if you go to that link there, you'll be brought to our documentation about the change feed pull model, where instead of the push model like we talked about today, you can read the change feed with a pull model. And the big theme of the pull model is you have more control as a user. Now, in addition, coming soon in private preview, we have what we call the full fidelity change feed. And actually, this name is still being worked on. I don't think that's really the best thing for the feature.
We call lots of things full fidelity, it seems like. I don't know. Yeah. It's like we can't think of the name. Full fidelity, whatever.
It's better, right? Full fidelity is just like another way of saying it's better. There's more stuff. So it's the change feed now, right? Except it's also going to have deletes and intermediate updates. So the change feed now is like a feed, basically, of the latest version of the document. This will be a full Cosmos DB operations log that we expose to you as a user. This will be a little different because unlike the change feed now, this will not be free. This will have a small, not too significant, but small cost associated with it by the time we go to GA. But if you're interested in giving feedback on this feature, if you saw this video, you like the change feed, and you want to try out the preview, please sign up here. We have had a lot of interest so far, so I can't guarantee when we'll get to you if you sign up, but I do guarantee at some point, like, you'll hear from me if you fill out that link to sign up for the preview, and I can certainly offer you like an update on timelines and kind of when we're able to allow you to try out that private preview of the feature. In addition to that, we also have change feed with filters, like I talked about earlier, where basically if you wanted to have a filter predicate to filter the change feed results, I mean, you can do that as well. That's not yet in preview, but that's being worked on now.
That's the one for earlier when you wanted to filter by logical partition key.
Mm-hmm.
Yeah. Right. Speaking of which, Kazuyuki's got another question or comment. In the demo where you were basically doing the materialized view, could you also use it to write to, say, a completely different database, like SQL database?
You totally could. And actually, that scenario is pretty common. Like it's. I mean, like if you think back to the original problem that you're solving with that, right? Is every database has its pros and cons, right? In the case of replicating data to a different collection that was partitioned by another value, like it was an extension of that same problem, right? Like one collection was better for querying one way, and another collection was querying better a different way. So the same is true if you compared like SQL DB versus Cosmos DB. I mean, there might be certain queries that you find are better in one database than another. So I mean, if let's say you wanted to use Cosmos DB for ingestion, and then you wanted to export data maybe to like a legacy application that had a dependency on SQL Server, right? Just for example, or SQL DB. You could do that as well. You could send that data to any data source that you want. Same thing is true if maybe you wanted to send it to like a colder storage. If you wanted to send it to Azure storage, since it's like a cheaper per GB cost and cheaper lookup cost, that would also be a totally good destination for, I mean, data that you read from the change feed.
Yeah, in fact, that's a common use case scenario because we don't offer a long-term backup right now. So that's typically what we tell customers to do is use change feed, write it out to blob storage, and you can keep it for 7-10 years, whatever your regulations require of you. The other option too is if you're going to send it to SQL Server, but your eventual target is to do OLAP queries or analytical queries with it, then in Synapse, just turn on Analytical Store. Do it, send it that way. So you wouldn't even need change feed. In fact, it wouldn't cost you anything at all to get it into Synapse, other than just the cost of the Analytical Store, which is basically blob storage prices. So that's another option too.
Yeah, I mean, it's the beauty of it is you think of what Cosmos DB is really good for, right? It's great for ingesting data, right? You can ingest a large volume of data quickly. It's great for scaling, right? You can scale out really well, and it's really great for availability. So in lots of scenarios, it certainly has a place, right? Even if it's replacing like a small component of a legacy application, like it offers a lot of value, like scale and availability, like in almost any workload, that's like of most importance. So that scenario where maybe there's a different part of the workload that's, I don't know, has a dependency on some other database that you send data to. That's a totally good use case for change feed.
This isn't a question, but apparently we're reading minds here in our comments in our discussion. So thank you very much. Yeah.
That's awesome. All right, cool. So that's all I have for today, but I'm happy to answer any more questions that any of the viewers have.
I think we've pretty much hit them all. If you you got any questions, write them fast because we can't take them after the broadcast here. So, but yeah, this is great. Definitely my favorite feature. Continues to be, always will be. I love it. Love talking about it. Love writing demos around it. It's just, I mean, what would Cosmos be without change feed? It's an amazing feature for our database. So yeah, thank you so much, Tim. Another great episode. Lots of questions, lots of people watching. So thank you very much.
Cool. Thank you, Mark. And thank you everyone for watching.
Yep. Next week, I've got Saranya on our team who's going to talk about monitoring. We've been doing a ton of cool stuff around monitoring and integrating Azure Monitor workbooks and all the other cool features into Cosmos. Definitely check it out in the portal. You can see it there now. We've got our metrics and then metrics classic, and then another tab in there called Insights, which is essentially us taking the classic metrics and then redoing them using Azure Monitor. So get in there and check it out, and then come see us next week. You can ask Saranya any questions you have about our new monitoring in Cosmos DB. So that's it. Thank you, everyone. We'll see you next week. Thank you, Tim.
Sure.